Hello and welcome. This is a demo video going through Mu Ren Zhuang step by step, explaining the steps. I will not do any coding, that would take too long. Mu Ren Zhuang is available through GitHub. If we go to the introduction page on the wiki, so it's a wiki, you will find a short explanation on what it is. It's a procedurally generated exercise system aimed at helping developers practice maintaining coding energy, refactoring TDD, designing for flexibility, and all of that amounts in surviving in a dynamic world. The basis for MRZ, or Mu Ren Zhuang, which I'm probably pronouncing horribly wrong, is that practice makes perfect, and you will not get flexible code if you do not flex it. Mu Ren Zhuang, as it is a web page with JavaScript. I've already downloaded the latest release, which you may find in the source code, and then we go to release. There you have tar and zip. The version is 1.2. So starting, this is the root program, as it's called. Mu Ren Zhuang will, through this graphical representation, ask you to implement a system. The first system is always the same. It's something coming on standard in has to go to standard out. Effectively, echo would be this program. When you feel that you have implemented the root program and you have tests for it with 100% coverage and refactored, you may go to the next step. This is the first step in our iteration. You will notice that in the left side we have a history, add mutator. This was not here before. A mutator is an entity through which the input flows. Input flows from standard in through this and out to standard out. Now we have two paths in our program. We are no longer in the root program. We are now working with the system. Each of these features should be selectable somehow, either through command line or any other mechanism of your choice. The important bit is that we have still something on standard in directly to standard out, and the new something on standard in goes through this mutator and goes to standard out. Now you're asking yourself, what is a mutator? And the natural question, what is this coming in? Everything coming in to the system is defined as being alphabetic characters A to Z in lowercase and uppercase, and numbers 0 through 9. You can find this in the wiki. It should be on basics of MRZ. Here we see standard in. Characters A to Z and numbers 0 to 9. No other characters, white space, etc. The standard out, it's the standard out. You have output files, you have mutators, and the root program. Mutators are part of the functional core of the system and are what actually modifies the input data. So you could think of it as a function. It actually is a function. And if we go further to read, you have a short description on mutators. This particular mutator has buffer 3, a transform increase, and an indexing sequence. This should be read as the buffer, whatever comes in, it will store internally up to 3 of whatever comes in. On the fourth element, be it an alphabetic character or a number, it will execute this transform function within it. This is the increase function. Where can I find more information about the transforms? It can be found on the wiki. We go to pages, where we see all pages. We go to transformation functions, and here we have a full list of the functions: decrease, increase, type, copy, sum, and code. Now we had increase. So remember, buffer 3, we are buffering the input. We're not yet generating any output to send it out. So one element comes in, a second one, a third one, and on the fourth one we run increase. We go to increase. Here we have it. It will return an output sequence, an array of size equal to the length of the indexing array. We will come to that, where each element is increased by 1. For numerical elements, the increase is modulo 10. For alphabetical elements, they are increased. Should this be actually? That's a bug on camera. Excellent. Modulo z plus 1. So if I'm increasing 9, I get 0. If I'm increasing z, I get an a, and it cycles around. Now this indexing sequence, this has 3 numbers. This indicates the order in which the transform gets the elements. So we had a buffer 3, that means that we have numbers 1, 2, and 3 that we can index. So we're picking which data to run with the increase. And we have a 4. So the 4 dictates the current elements. So for the increase function, we will take the first seen and buffered data element, the second seen and buffered, and the last one. So for an input sequence of 1, 2, 3, and 4, this will be 1, 2, and 4. So the output will be 2, 3, and 5. There are examples for every transform that should be clear enough. If not, they can be made clear. Next, you press done. Of course, you only do this when you have implemented, refactored, and implemented. Since this is also practicing TDD, of course means that we first have tests and then we make it. Now you will notice that it's no longer green, so it's now part of the system. It has solidified. I may go on to the next step. The green is the new. Add a mutator. I'm now a level 2 noob. This means that I have 1, 2, 3 paths through the system. I have 3 features. This new feature will actually be transform decrease. That output goes to buffer 3, transform increase, to standard out. And I have the previous one. Something comes in, goes through this mutator, and goes out. And the root program feature. I can read about decrease on the wiki page for transformation functions. Here we have it. It's the inverse, of course, of increase. If I have A and I decrease, I get Z. If I have B, I get A. If I have 0 and I decrease, I get 9. If I have 9 and decrease, I get 8. Once implemented, I also need tests, of course, for the feature, going from standard in through this whole chain and done. When I feel satisfied, I refactored, I press next step. This is the new. You haven't seen this before. This is an output. The output file could be attached to any node, except an output file. So this is whatever comes in on standard in goes directly to a file on disk called file42. We now have 1, 2, 3, 4 paths, 4 features to maintain. This is all it is. Write to a disk. Done. So this was add output. I am now a level 3 noob. Next step. Here we got a new feature. Increase. It's still increase, increase, decrease. nothing new. The buffer is 4, so this element will buffer up to 4 data, and then the 5th index, if it would have been used, would be in the current element. It's not seen here. So what this is doing, it's eating 4, returning 2. So it's actually halving the amount of data going through. Once implemented, I press done. Next step. Now we got a buffer 3 encode between standard in and the file. We now have 1 root program, 2 directly to file, 3 through a mutator to file, 4 to this one, buffer increase 3, 5 through these two, and 6. We have 6 different features. This new one still depends on going to a file on disk. Encode is a little bit special. We'll look at that one. Returns an array where every targeted element changes domain. Integer elements are encoded as alphabetic characters. Alphabetic characters are encoded as integers. We have examples. So A becomes 1 and 1 becomes A effectively. Once this is implemented and refactored, and I will probably have some common patterns and tested, of course, with feature tests, I'm done. I am now a level 0 beginner. I can press new, next step, and now there's a new feature that whatever went through this mutator goes to a file. Done. And so it goes on. It will grow and grow and grow. Of course, it will not only grow in absurdum forever. Eventually, around 15, 16 mutators, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it will ask you to start removing randomly. It could target a file or a mutator. If it targets a file, all mutators in that chain are removed unless they are part of another path. So this is what happens. I think that was all for the quick overview. I will upload another video detailing in one case for one mutator step by step what happens, so you learn how to interpret them. That was all. Thank you very much, and good evening.